I'd like to introduce Peter Stricker next. He's the CEO of P4P, and he's going to have to read this one, so long one. Innovative, multiple value solar technology anywhere and everywhere.
Great. Thank you. Good morning. It's great to be here. I'm the start again. As the CEO of P4P Energy, I want to share the story of the company with you. I'm here with two of my colleagues, Stephen Cogner, who is the founder and chief design officer for P4P, and David Hofstatter, who is chairman of P4P Energy's board. In our presentation, I'm going to tell you about P4P and the basics about our technology. Stephen is going to share a story about projects we recently completed in India, and David is going to talk a little bit about our approach to social integration of solar. Just a quick paragraph about myself. I'm a longtime renewable energy professional in both wind and solar. So I've worked for several companies along the way, including Clipper Wind Power. I was a founding member of that team. I also worked for Energy as Vice President of Renewable Energy in the Northeast. And recently I was with a startup in the solar thermal space called Edison. So to start the story here, so Stephen, as founder, originated the vision of P4P back in 2003 when he filed the first patent for tension cable suspension of PV panels. Today, P4P is a product and design company creating efficient cable structures capable of large-scale deployment that by design serve more than one purpose than just solar generation. So this is probably a subject I'll bring up with Adam after this presentation, but 1% represents the current penetration of solar energy in the US electric market. In the late 1970s, my father went to work for SERI, which was the Solar Energy Research Institute, now known as NREL in Golden, Colorado. At that time, solar was primarily meant solar thermal, as PV was extremely exotic and expensive. 35 years later, PV is now a commodity, having seen astounding cost reductions, especially over the past 10 years, with current installed base in the US of over 40 gigawatts. PV now provides 1% of the US electric energy supply. One percent is a fantastic achievement, but is only the tip of the climate change iceberg, so to speak. Excuse me. To get to a level where solar is substantially offsetting fossil fuel-based electric power, say 30%, as Adam cited previously, solar deployment must accelerate substantially. If at the rate of 2016's build-out, achieving 30% PV penetration will take 80 years. As 80 years is a lifetime we cannot afford to spare, how can we speed this process up? So-called solar integrated infrastructure embodies two important concepts. One, to make a significant contribution to carbon-free energy supply, solar must be implemented at the scale of large infrastructure, such as the US interstate highway system or the canal system in India. And two, to do so with greater motivation than is currently driving the solar market, solar infrastructure must take full advantage of economies of scale and be deployed in combination with other infrastructural values. This thought of other infrastructural values is really core to what we do as a solar structure company. So this integration allows competitively priced energy plus shade, which mitigates evaporation, reduces UV damage, enhances crop production, reduces building AC loads, plus land conservation by installing solar over existing land uses. So this is a little snapshot of one angle of how our technology looks. The system is intrinsically simple. It's lightweight and cost efficient. It consists of tension cables mounted on columns to form cable trusses. So you'll see across the middle of the screen of the cable truss is actually two cables that are tied together. anchors and tie downs sustain tension in that truss, then what you can't see is clearly in this view, but we have between pairs of cables, trusses, we have what are called space frame pods that carry the solar panels. So the whole configuration is to be as light as possible and afford itself to be off the ground and over large spaces. So shown here is an example of our technology from a project that we're working on right now in Hawaii. This is a building top solar project that has parking on the roof and commercial space underneath. And so the idea of this particular installation is not only to generate power, but also to provide shade to reduce the air conditioning load in the building. Achieving big. So achieving scale and moving 1% towards 30% is P4P's all-consuming mission. And fortunately, our technology lends itself to this. A thumbnail of our addressable markets includes, in the canal space, 4,000 kilometers of canals. In California, there's 600 plus miles of canal. In the parking space, we have 2 million acres of uncovered parking area in the US, which equates to something like 200 gigawatts of potential solar parking. In agriculture, we have the Central Valley, which is roughly 18,000 square miles of land. If we only covered 10% of that land, we would be able to produce 230 gigawatts of solar. And then last but not least, in New Jersey, there are 846 landfill sites that would be perfect candidates for our technology. So that's really only a snapshot of what's available in the solar market for P4P's, the opportunity for us to build solar projects. Okay, so now I'm going to turn it over to Stephen Cogner, who, as I mentioned, is our Chief Design Officer and founder. Stephen has worked tirelessly for many years to bring P4P into the light and continues to be our technical and operational visionary. As protege of Buckminster Fuller, Stephen has centered his life and career around Bucky's mandate to him to, quote, build structures that support humanity. Stephen is also pretty handy to have on site during construction. So, Stephen, please go ahead and share your story.
This is a picture of the Indo-Gangetic Plain, part of it. You see the Himalayas on the upper right there. And this is the area that Lester Brown was talking about yesterday. This is an area of maximum water aquifer depletion. There's 80% of the glaciers melting in this area. So having studied Lester Brown for 25 years, it was really exciting for me to see him yesterday. And having studied directly with Bucky, he used to stay 3 weeks a year at our house when I taught an environmental design course at WinStar, and I'm still on the same project all these years later. Anyway, it was identified to me earlier, especially after reading a book called Water Wars in Asia, that this was an area of critical concern. So this led me to move our integrated infrastructure to India early. So I think it was 4 or 5 years ago was the first trip I took to India. I went to a solar conference there, and I just went to see what was going on in India. It was in the Gujarat, and I happened to show these integrated systems of over agriculture, over parking, over roads, over canals, to the Minister of Energy and Petroleum. I was the only one that he took to see Mr. Modi, who was then the chief minister of Gujarat at the time. He actually had brought all his ministers, resource ministers, that water, energy, agriculture, together. And he is well aware of the problem that India has. India knows that they have a problem. They know these aquifers are going down. They know that a critical situation is coming up. This is actually 1/7 of humanity lives in the Indo-Gangetic Plain right here. So this was a motivation for me to actually start there. When I met with Mr. Modi, I showed him our systems, and he said, to us ministers, is this what we've been looking for? And they said yes. And so he wanted to start on a 105-meter canal, but then he got too busy getting elected prime minister. So, but we kept working ahead, and he actually did institute over-canal subsidy based upon these conversations that we had after he became prime minister.
4 minutes left.
4 minutes left. So I'm going to go really fast. So, okay. So next slide, please. So here is a P4P system over a canal that we just built. This, okay. So and this, I just built this in. Actually, we had the foundations up, and the rest of this structure, from the columns to the installation of the system, we built in 2 months. When I got to the site, I could see that, as you can see, this thing goes around the corner. It was I was more excited than I've ever been in my life, and also intimidated that I had to finish this whole thing in 2 months. Next slide. Here's the project under construction. One of the projects, we built 2 projects. This is an east-west orientation canal, so the panels are tilted to the south. Next one. This is the back of the completed system. There's a walkway to the combiner boxes right here, and you can see our space frame structure, although this is not the best picture of it. Next, please. We also built the north-south canal, which required a different configuration. The reason the panels are at an angle of the canal is because we wanted to face the customer wanted to face the panels due south. This particular system, we have about a 90-degree adjustment from east to west that we can do so we can adjust to the azimuth of the canal. So we can build hundreds of miles of this canal. Next. This is a side view of that particular system, and you can see the cable structure, how little structure is required to hold up the solar panel right there. Our systems, there was another project built over a canal before us, a 10-megawatt system. It used 225 metric tons of steel per megawatt. Our system uses 85 metric tons of steel per megawatt. So there's a fundamental resource and embodied energy advantage to these systems. Next, please. It wasn't all kumbaya to get this built in 2 months. Construction is a yang sport sometimes. And this was the 2 different construction teams at a particular moment of let's say, intense conversation. They said, we're going to yell at each other for 10 minutes in Hindi, and we can't switch to English. And at the end, we'll be okay, but just don't, if it looks like we're going to kill each other, don't worry. Anyway, so this was an amazing cultural experience because the building technologies and everything was different. Next slide, please. So then, in the middle of our construction, this is the committee for the environmental benefit of Ludhiana, which is actually a relatively polluted industrial town in northern India. They showed up with a reporter from the Times of India in the middle of us building this big project, which could have been good news or bad news, I guess, but it actually turned out to be good news. And they got so excited, and they're regularly bringing people out to show our project as an example of the way their state should develop. The state of Punjab actually submitted our project as an example of good governance competition of all the states to the center in India. Next slide, please. After they showed up the next day, there was an article in the Times of India. And in this first communication to the people of India, there was all the multiple benefits of the reduced evaporation, increased fish production, reduced salinity, all these kinds of things were put out in the world. And it was also put out that this could cover hundreds of miles of canal and be a major contribution to the resources of India.
I love the caption on that, Stephen, which if you can't read, it says, a man points to the solar panels and the Sidwan Canal, and a man is Stephen.
I never felt more alive than building this project and more terrified at the same time. At the end of the project, it being India, this Indian sadhu came up to me and handed me his Ram stick, which he'd been carrying since he was an adolescent, and which he's not anymore. And he gave me this blessing because he thought that this was a contribution to the community. And the response and the honor that they gave us for bringing this system to the community was amazing. It wasn't the NIMBY or the white guy comes in and tells us what to do at all. And the uneducated workers, by the time that they finished this project, they were working 5 times as fast, and they felt pride of ownership of having this in their community. So it showed it as that it actually can be community building, and there were Muslims, Hindus, and Sikhs on this site, and I didn't know which was which, and there was a very democratic and inclusive relationship to those kind of separations that we have now. Next. So there was a festival at the Indian Sikh temple, and this was in the middle of construction, but the head of the Sikh temple became my buddy who gave me like buckets of prasad every day, which I go around and hand out to every worker. So, and this is like the Starship Enterprise landed in their community, but they loved it.
Thank you, Stephen. Okay. That's great. Yeah, that was pretty cool. I'm really sorry that I wasn't able to join you. That looked like an amazing experience. So in addition to the experience that we gained on these projects, what we found truly exciting is that they represent, for the first steps, or perhaps a giant leap towards big solar integrated infrastructure. However, as we heard earlier this week, small is the new big, which, as David will explain, is also a priority for us. David wears 2 hats. One is the chairman of our board, which he's been instrumental in organizational development as well as fundraising, and the second as the key architect of Tango Lab, an incubator for tech startups focused on social systems innovation. With that, David, go for it.
Thank you, Peter. This is the first time I've actually seen this material, Stephen, presented so eloquently. And yeah, I just want to say what an honor it is to work with a visionary who can carry a narrative for like 25 years and get to the point where the stuff's on the ground. This man has tirelessly been carrying this sort of Bucky-inspired vision. And it's a wonderful moment in his life, and I'm honored to work with him. And then, of course, you have this amazing visionary carrying this narrative who also gets stuff built. And then you've got Peter, who can carry the operational execution with decades of experience in doing that at the close to gigawatt scale, and has been a pioneer and a space holder in renewable energy, including his father, so generational space holder. So what's there left for me to do? Well, generally speaking, we're going for full stack vertical integration between the blockchain, community solar, social networks, and the technology like Airbnb and Uber that can cause us to share a solar asset like we share our homes and our cars today. How many people have had the experience of time sharing their home or participating in an Uber experience? Any of you have a sense of a higher sense of community than staying in a hotel or riding in a taxi? So there's some interesting properties that come in when we look at the world and we realize that we have enough assets, and if we just shared them, we could reduce the carbon footprint of human activity. So that's kind of what we're looking at in terms of diving below the physical infrastructures of cars and homes and energy producing plants, and looking at what the role is for community organizing social networks, and more importantly today, especially with Patrick and Nick and Theo here in the room with us, all representing the trends happening in blockchain. What is the role of this fantastic new decentralized web infrastructure? And so we're trying to use this framework that I'm sharing with you here today to create a sense of opportunity for those that are building physical infrastructure to integrate with these trends. and build full stack integrated solutions where all the technology sort of comes together in support of climate, not just these sort of more obvious physical layers. So this is a key piece of a tool set that runs in an incubator where 4 times a year we have people coming into that incubator, entrepreneurs typically called to purpose in their heart, who are really activated to build stuff in the world more collaboratively. And they sit with people who are really outside of their world. We have P4P holding this vision of physical infrastructure, sitting with folks that are really versed in the world of the blockchain and the world of putting together a tech stack to build a new social network. And that diversity creates a lot of opportunity. We see this in nature, where diversity is really the root of creation. So we're harnessing that diversity through more of a collaborative environment for innovation to kind of come up with some really new, interesting business opportunities, not only to put integrated technology into the world that has lots of synergy and what Barbara Marx Hubbard calls social synergy, and efficiencies, economic efficiencies, but also to get these systems into the world in a way that's cooperative between these project leaders. So, Bucky used to say, what's the quote, Stephen? If we're going to solve this mess, we're going to need cooperation, not competition. That's a recurring theme here.
Any system that's not cooperative is not efficient enough for this evolutionary challenge of humans right now. So that's what Bucky said.
Yeah, and I thought to start my presentation with a gratitude, and I'm going to take this moment just to name how grateful I am for the indigenous, generationally kind of holding space on this land and all lands living in coherence with nature. And all the species, the winged ones, the four-leggeds, all the two-leggeds too, not just the indigenous. And we're really in service, I think, of creating new infrastructure so that our culture can return to coherence with nature. So while I'm going to geek out here in a moment and get really down into the technical nitty-gritty of how this stack might get organized and really make a difference, I just want to let everybody know that pretty much everything we're doing in technology and business and sort of grounded transformation of what it means to be for profit, for purpose, really rests in that principle of honoring nature-congruent design and a lifestyle on the planet that's sustainable. So the first thing I wanted to share is kind of a way of orienting to this diagram where we dive below the physical infrastructures and the asset categories, and we kind of really start to understand that what Airbnb and Uber are doing is they're creating asset-sharing networks using purpose-oriented social networks. So there's a community in Airbnb and there's a community in Uber. And that community automates the process of an asset holder sharing their asset with someone else so that we get higher asset utilization. So there's social impact, there's positive climate impact coming out of something that may not have intended to have that result, right? Well, these trends in social structures are going to expand beyond just the vehicle fleet and the underutilized housing inventory. They're going to show up, thank you, in enhancing community solar. So community solar is a great term. It's the perspective of the solar world, imagining that solar can be deployed in a community, but there's also solar communities. If you turn that around and you make the community the object, you start to imagine what that means in terms of what we're building. So what's interesting here is that community solar or solar communities, or solar community networks, are different than Airbnb and Uber. Airbnb and Uber are asset categories where we had an oversupply of underutilized assets on the planet. We figured out a way to use social networks to share it. And that's a good thing. In the case of community solar, we don't have an oversupply of solar assets sitting in the middle of communities that need revitalization, right? So we're going to have to build these things in order to enable community solar. We can't just repurpose existing ones, which is where the blockchain comes in. Wow, right on time, just in time. So Uber and Airbnb weren't built on top of a decentralized web with new systems for value exchange and trust. They were built on the old platform where if somebody gave a review in Uber or Airbnb, which we do, and we rely on those to select who we want to ride with and who we want to stay with, that review is not stored in the blockchain. It's stored in the old-fashioned in a corporate database. And we trust Uber or Airbnb that we can rely on that, right? In solar, we could do it that way, right? We could have essentially all the trust and the currency exchange and the value exchange and the disaggregated ownership of the solar asset held in the old-fashioned. But it wouldn't give us a new method of removing the financing friction. What blockchain brings to community solar is essentially a crowdfunding approach to community ownership of that solar asset based upon the issuance of a solar coin. So how many people in this room are, like me, pretty challenged to understand what the heck blockchain really is? Thank you. All you people who didn't raise hand, can you just show up at lunch and explain to me what it is? Because I still don't totally get it, right? This stuff is really heady. I mean, it's probably worth it here. I'm going to wrap up in about a minute to just mention that blockchain essentially provides the vehicle for financing and more to community solar in a really powerful way. Because not only do we get a way to divide ownership of an asset, we also get a certifiable way to trust the system that we're building. It actually is a whole new platform where the users who are involved in a community solar program can gain livelihood going forward by participating first in that community build. If they're not able to put up cash to purchase a panel or a pod of panels, they can put up their labor. And their labor can be certified in the blockchain using crypto and cryptography and stored distributedly. So now we have new methods of providing value and getting that value certified in order to own a piece of that asset. So this is subtle, but it's really significant. And then there's this whole series of other benefits if we're building a community-owned solar asset that are kind of in the realm of the subtle, where people participating in that solar asset, either as supporting the development stage of getting permitting and finding a site, or in the construction phase, maybe you have student volunteers doing community service hours putting together these space frame pods. This is a beautiful vision right there. Now they've finished a volunteer project where they're getting community service hours to graduate, but they also have an equity stake in that solar platform. Livelihood. Livelihood in a regenerative industry. Maybe they were really good at it, and the community down the road is going to start up a community solar program, and they're going to be the supervisor in that community down the road. And if their reputation is stored in the blockchain, it's totally reliable, right? So this is a way, essentially, for the next generation of millennials to partner in a community holding a solar asset that empowers them into right livelihood, right? That's really significant. We're creating a platform for income and economic development that's never been really seen before, which is exactly what we need for resilient communities. Okay, so just in summary, there are two tools that the incubator is providing to support this. On the left, we have an innovation methodology that can weave together folks from different worlds at the blockchain, the social technologies, and the physical infrastructure layers, as well as a series of protocols once we figure out how these pieces fit together. I invite you to consider experiencing this lab in the future. Our next one is in LA in October, and there's a website that you can visit to see how that works. And we also have a protocol stack project that's a nonprofit that'll have a website launching in the fourth quarter. And there's some very interesting protocols for profiling collaborative projects so we can create visibility around the world on what we're working on, CPML that'll go into the IETF this year. We're almost out of time.
Just about out, yeah. So
the last point is that this can be highly simplified down to the fact that trust in the core networks, the new generation of technologies in the blockchain, drives collaboration that we need to address these challenges. And that collaboration at the social structures layer is what enables us to trust each other enough to converge our physical infrastructures. So trust drives collaboration, drives convergence. So we can actually get a simple narrative. Peter?
Okay, we have 15 seconds, so no time for questions, unfortunately, but But the three of us are going to be here for the next 2 days. So we're all here, and we'd love to sidebar with any of you to know more about what David's doing and more about P4P. But thank you all for your attention, and we really enjoyed